Hello and welcome. My name is Vishwanath M. In this video, let us try to learn and understand the concept of conversion of infix expression to suffix or a postfix expression. If you are following the VTU syllabus, this is program number 4. Let us have a brief introduction about the program. So there are three types of expressions: infix, prefix and postfix. Infix expression is the normal method of expression or the normal expression of operations that we are used to from school days and what we normally write for all mathematical operations. Suffix expression, on the other hand, is the computer preferred or the calculator preferred expression method or the type of expression. In one of the earlier videos, we have seen the evaluation of suffix expression. So in this video, let us try to learn how to convert the infix expression to suffix expression. And there is an interesting image here. It is good to remember this image because that forms the logic of the program itself. There are so many versions of the program, and this that I have used here would be the easiest to not only remember but also explain the program. Like any other C program, there are a set of header files included, and for its own purpose, they are imported into the program. For example, since there are input-output operations, there are the stdio.h header file is used, and since there are expressions like string length or functions like string length is used, the string function is used. So one is required to understand why we are importing the header file into the program. So before we come to the main function, we see that a few global parameters are defined, being a character stack of 100 and int top is equals to -1. So we have initialized top to -1, that is understood for all stack operations, and we have created a character stack of 100 size in order to consider a big enough expression. So since we are using the concept of stacks in this program, we would have to implement, or we would have to use the push and pop functions, and what you see here is the simplest way of implementing or simplest way of writing a push and pop function. So push function need not return anything, and hence the return type is void push of character x. So every time the push function has to be called, something has to be sent to the calling to the function. So when the calling function calls the called function, a parameter is required, and that parameter has to be of the type character. So all the push function does is increments the top operator. So what is happening here is a pre-increment of top. So if it was -1 in the initial scenario, first it would be incremented to 0 plus top, and then the stack of top would be occupied by the parameter, that is x here. So that is the push function. Pop function, on the other hand, has to return the character, and hence the return type is character, and nothing has to be sent to the function, and it could just be called, and hence the parameter list is empty here. So if the top is equals to -1, that is, if the stack is already empty, essentially there is nothing to pop, and hence in that case we will have to return -1. Otherwise, in other cases, we are just returning the topmost element of the stack, and what you see here is the post decrement. So first assume that the top is here. So stack of top minus would essentially return pop plus first, and then decrement the value of top. So that is post decrement, and what is happening here is pre-increment. These are push and pop functions. A crucial part or a very important function in this program is the priority function. So this is where the this image also proves to be of relevance. So first let us understand the function itself. So priority function is used to assign a priority to the operators. So we see there are multiple operators here, plus, divide, star, and even the parentheses have to be considered as operators. So all the others, that is a, b, c, d and e, they are operands. So you have to assign a priority to each of them. So that is how we would convert an infix expression to a postfix expression. So since even in our normal mathematical sense, the brackets do not imply a mathematical operation, and hence their priority or importance is lowest and is used as 1. And if the character, that is if the operator is plus or minus, addition or subtraction, addition and subtraction hold the same priority, and it will be the second smallest, so it is so the priority of addition and subtraction is assigned as 2. For multiplication, division and modulus, that is remainder operations, the priority is 3. And for power operations, that is these two are the methods of implementing the power operations or expressing power operation, and for that the highest priority with the priority value of 4 is initialized. So there are other versions of this program where the priority values are much more different, but this what you see here is the simplest and one of the easiest methods to remember and understand. So and to make the program much more readable and pleasant to look at, so I have typed the return function in the same line as if function and aligned all the return statements in the same line. But one could also bring the return statement to the next line and indent it properly. So we have understood the priority function. So if in order to create a default case when the operators are none of these, so we will create a return case with again the lowest priority possible, that is 1. So we have understood the priority function. We have seen what the priority function does, but why and how it works in the program, or why is it required, we will get to know in a little while. Now coming to the main function where the execution of C program starts. So inside the main function we have created a character expression, that is in order to hold the whole string or the expression itself, and again in order to consider a big enough expression we have created with a size of 100. We are also creating two temporary variables, char symbol and a, and int I is equals to 0. I is one would guess that it will be used in the for loop, so it is a iterary variable. And in the main function we will print the statement enter infix expression, and we will accept the input using the scanf function. Once the expression is entered and it is accepted, we will just print the statement that postfix expression is, and we will enter a new line, and here is where the whole conversion of infix to postfix takes place. Now before we understand the for and while loop here, which forms the heart of the program, I will give a very brief logic or a very brief understanding of the whole while and for and while loop here. So even in the normal sense we would process any expression from left to right. So and hence I have denoted the same in the arrow here, and hence even in the for loop you would see that the iteration starts from 0 being the leftmost or the starting position of the expression. So even in the normal sense we look at expressions from left to right. That's the first point. And when we are evaluating an expression, or when we are seeing an expression, we will always have to consider the priorities. So forgetting the program, when we are asked to calculate an expression like this, we will have to first see what the operators are, and depending on their priority or depending on their importance in the expression, we will have to calculate the value of the expression. So in order to remember what is the logic behind that, one could remember this image. So just like how it looks, so assume that the smiley at the top has a higher priority or is stronger, and the smiley at the bottom is of a lower priority or it is weaker. So this is the harsh reality. So as long as the incoming candidate or the expression of higher priority comes, the lower priority will have no other option but to accept or but to allow it to sit on top of it. So it's a very vague way to remember, but it forms the logic of the program. So one would have to understand that as long as the priority or the importance of the operator is higher, the existing parameter will allow the incoming parameter to sit on top of it. But if the incoming parameter is of a lower priority, if it is suppose assume or imagine a weaker candidate coming in, so the existing parameter or existing symbol in the stack, assume that this is one could understand this is the stack. So the symbol or the operator already inside the stack would not allow a lower priority operator to come and sit over it, but would just pop out. So assume that all the operators inside the stack are waiting to get popped out, and they would pop as soon as they see an incoming character is weaker than what they already are. But when it's a stronger one or when it's a higher priority one, they would have no option but to allow the incoming symbol or operator to sit on top of it. So it's a very vague way of remembering the program, but if it helps, that's all is intended. So that was the purpose of this image. So we don't need this anymore. Now let us try to learn the for loop and while loop itself, and then I have also dry run the program where I have explained, or I have visualized what happens in each iteration. But first let us understand the for and while loop itself. So for I is equals to 0, starting from the leftmost position, I smaller than string length of expression, that is it has to traverse the whole length of the expression, and I plus plus. So since each symbol or each character has to be processed, we are incrementing by 1 or I plus plus. So inside the for loop, first we will consider each element. So in the first iteration, expression of I would be holding the opening parenthesis, so it would be temporarily it would be stored in this variable called symbol. And once it is stored in symbol, we have a set of if-else constructs or if-else conditions. So we will take into consideration the symbol and test it against different conditions. So if the symbol is a alphanumeric value, in other words, if it is an alphabet like this, A plus A, B, C and D and all those, or if it could also be a numerical value like 3, 4, etc. So if it's a alphanumeric value, the logic says it just has to be printed. It's print C of symbol. Where will it be printed? So we have printed this line, postfix expression, and we have come to a new line. So whenever the print statement is executed, so it would automatically print in the next line of postfix expression. So if is alum of symbol, we print the symbol itself. So this was the first if condition. Next, else if symbol is the opening parenthesis. So whenever we have an opening parenthesis, now one has to remember the program is aimed at converting the infix to postfix or suffix expression, and this is the logic behind that. So else if symbol is the opening parenthesis, we will just push the opening parenthesis into the stack. So that is what is happening in the first iteration. We will understand the dry execution of the program later, but let us understand the program itself now. So else if push is equals to the opening parenthesis, we will push the symbol into the stack. Else if the symbol is a closing parenthesis, if the symbol is a closing parenthesis, the condition or the logic is as long as or while A of pop is not equals to the opening parenthesis. Now one could understand the program. So initially we would have pushed the opening parenthesis into the stack, and when it sees the closing parenthesis, it is like all the contents of the brackets or all the contents of the expression are inside the stack. So while A is equals to pop, but it is while A of A, which is just holding the return value of pop. So in other words, whatever is returned, if it is not equals to the opening parenthesis, so as long as it is not equals to the opening parenthesis, we are just printing the symbol. So it is totally understandable. So we will further understand the program, but one could correlate that once the closing parenthesis is seen, the program has to print the contents inside the stack. So that is what is happening here, but it need not print the parenthesis itself. So one could see here when the pop when pop function is returning the when the pop function is equal to the opening parenthesis, print won't be executed. So that is why in the output expression you would never see a opening parenthesis. That is one way to check if you have correctly executed the program. When you execute the program, you should not see any opening parenthesis in the or for that matter, you should not see opening or closing parenthesis in the output screen or the output window. Okay, so let us now, we have seen what happens if the symbol is opening parenthesis and also the closing parenthesis. Now let us consider the case when it is neither of these two. So else, when the symbol under consideration, so in each iteration we consider each character by character. So in the first iteration it would be the opening parenthesis, second iteration it would be a, third iteration it would be plus, and so on. So in that iteration where it is neither opening parenthesis, neither closing parenthesis, and neither alphanumeric value as well. So it cannot be opening, it cannot be closing, it cannot be alphanumeric. So in that case, the only remaining is the operators, that is the mathematical operators like plus, minus, etc., etc. So when we see a operator, that is where the priority function comes into the picture. So we have seen this image already, this image of lower priority and higher priority. Keep that in mind and let us understand the program. So while priority of stack of top, so while the priority of stack of top is greater than or equals to priority of symbol. So understanding this line of program, when the priority of the topmost symbol in the stack is greater than or equals to, so as long as the contents inside the stack have a priority greater than or equal to the incoming symbol, so incoming character is symbol here. So as long as that is the case, I have told you already that the contents inside the stack will be waiting to get popped out. So as long as the priority is greater than or equals to the incoming symbol, it would just pop out and print. In other words, it is coming out of the stack. But in the case where the symbol has a higher priority than the stack itself, than the topmost value in the stack itself, this part of the program or this line of code wouldn't be executed because the while loop would fail, and in that case the incoming symbol would just be pushed into the stack. So that is when this line of code would be executed. So that is why this image is making a lot of sense and relevance here. So when the priority of the contents of the stack is greater than or equals to the incoming symbol, the contents of the stack will be popped out and it will be printed in the output screen. But if the incoming character or incoming symbol itself has a higher priority, it would occupy or it would enter the stack, and hence the push symbol is called. And that is essentially the end of the for loop. And while loop, as one could guess or one could understand, is executed after the whole expression is traversed, since that is also evident here. So for loop executes the number of times equals to the length of the expression. So it would traverse the whole expression. So the while loop executes after the whole for loop is done with the execution. So while loop is just used to empty the contents of the stack. So while top is not equals to -1. So if suppose there were some contents in the stack, so the while loop is just aimed, or is the objective of the while loop is to print the contents of the stack. So while top is not equals to -1, print pop. So print we are just printing the return value of pop here, and once the execution is done, or once the complete execution is done, we are just entering a new line and closing the program. So we have understood the program now. Let us, before execution, let us try to understand this dry execution, or let us try to iterate through the program manually. So in the first iteration, the symbol is opening parenthesis, and since it is matching with this condition, it is being pushed to the stack. In the second iteration, it is an alphanumeric value. So this line of code is executed, and hence it would be printed in the output screen. In the next iteration, the symbol is plus, and since none of these will execute, the else part here will execute, and the priority of the symbol, so the priority of plus is 2 here, priority of the opening parameter is 1, and since the priority of 2 is greater than the priority of the opening parenthesis, which is 1, so the while loop also doesn't execute, and hence the plus is pushed inside the stack. So considering the next symbol, B is the operator, or B is the symbol under consideration, and since B is an alphanumeric value, B is simply printed in the output screen. Next, in the next iteration, the symbol under consideration is closing parenthesis. In that case, this line of code would be executed, what you would see here. And as one can see, when the symbol is the closing parenthesis, as long as or until the pop returns the opening parenthesis, it prints everything. So what is there inside? What is there inside the contents of the what is there inside the stack is plus and the opening plus and the opening parenthesis. So as long until it sees the opening parenthesis, whatever is the contents of the stack, it is being printed in the output screen. So A, B, and plus is there on the output screen. So we are done with 5 iterations. Moving on to the 6th iteration, we have a plus symbol, and in the plus symbol, by the time the plus is considered as the symbol, we know that plus is already, the plus inside the stack is already printed on the output screen, and even the opening parenthesis is popped out. So essentially the stack is empty, and this new plus or the new addition operator outside the parenthesis will be pushed inside the stack, and that is what is happening here. While since there is nothing inside the stack, so it is essentially just pushing the plus symbol into the stack. So that is happening in the 6th iteration. Moving on to the 7th, since C is an alphanumeric value, this condition would be satisfied, and hence in the 7th iteration C is printed on the output screen. In the 8th iteration, we have a division operator. Here is where the priority comes into play. So the priority of the stack of top. So what is the priority of a stack of top? Priority of plus is 2, and the priority of symbol is which is divide. So priority of divide is 3, and 3 is the priority of symbol. It is greater than the priority of top, and hence this plus has to wait, and it can't do anything, so it cannot be popped out, and hence that is when this image one should remember the image. So since this would be the divide operator and this would be the plus operator, since the priority of divide is higher than plus, plus cannot do anything but to allow the placement of divide on top of it. So the push operation is executed, and hence you see divide on top of plus. Okay, now we are done with the 8th iteration as well. Next we have the alphanumeric character D. In that case, this line of code would be executed, and hence you would see it in the output screen. In the next iteration, we have star operator. We have star operator in the as a symbol. So when we have a star operator here, so again all these conditions won't be executed, and this while loop or while condition would be checked. So priority of stack of top. So what is the priority of stack of top? So the priority of stack of top here is currently it is a divide operator. The priority is 3, and the priority of the incoming character is also 3. So that is why for that condition, when the priority of stack of top is greater than or equal to the priority of the incoming symbol, it would just pop out. So in other words, one could remember it like this. So since in a case where both of them have a equal priority, suppose this has been there in the stack for a longer time, consider that as an experience advantage. So the older one inside the stack would be popped out, and the newer one will have to be so the older one, the content inside the stack will be popped out. So that is what is happening here. So that is why you would see that the divide operator is popped out. That is happening in the 10th iteration, and in the same iteration the divide which is popped out is carried out here, and the new symbol, that is incoming symbol, is taking or is being pushed into the stack. That is executed here. Just to repeat, the divide and star operator have the same priority, but since the divide operator is in the stack for a longer time, or like that is a way to remember, but even the code defines that if the priority of the topmost character in the stack is greater than or equal to the symbol, it will be popped out, and hence you would see that the division operator or divide is popped out, and the incoming character is pushed into the stack. That is why we have star in the stack now. So moving on to the last iteration of the for loop, that is the end of the string length. So the string length is 11 here. So in the 11th iteration, the symbol is E, which is an alphanumeric symbol. So that is as it is printed in the output screen. So that comes to the end of the for loop. So for loop has run for 11 times, or there are 11 iterations of the for loop. But even in the even even after the end of the for loop, this is the contents of the stack. So we have star and plus inside the stack, and we have the expression printed till here. So the while loop, as I said while explaining the program, the objective of the while loop is to empty the contents of the stack. So while top is not equals to -1, so it will just pop the content of the stack and print it. So in the first iteration of the while loop, the star is printed, so that is why the star is now not seen in the stack here. So in the first iteration of the while loop, to get some difference, I have used Roman numerals here. In the first iteration of the while loop, the star is printed, or it is first popped and it is then printed. And in the second iteration of the while loop, the plus, or the bottommost content of the stack is popped out and it is printed. And once the stack becomes empty, in the next iteration, obviously the top will be -1 and the while wouldn't execute, and all it does is it will just print a new line and close the execution of the program. Now we have understood the program, we have seen the dry execution, or we have ran through the program manually. Let us see if the program is, or the C compiler is implementing the same thing. So this is how we execute a program, GCC P4 being the program name. Whatever you would save the program as, that would have to be entered dot small c. Small c denotes a C program. If there are no errors in the program, you would see that the cursor blinking in the console, indicating there are no errors or warnings. If there are any errors or warnings, that would be displayed here, and that has to be resolved, and then again has to be compiled. So since there are no errors now, we can move on to the execution. And the way to execute a program is by typing this ./a.out. So it has started execution, and the first line inside the main function is printed, enter infix expression. So let us enter the same expression itself, a plus b plus c divided by d star e. So we have entered the same infix expression, and once we click enter, first it would just print the postfix expression is, and it would carry out all the comparisons and the relevant operations that we already discussed and we already understood also. So let us now click enter and see the output. So the output is clearly shown here. For easier representation, or for better representation, there is a space between the characters. Let us see if the output is matching with what we have seen already. So a, b plus c, d, followed by the divide operator, followed by e, and star and plus. So we have successfully executed the program, and hence verified the logic to be working correctly in the program. That was all in this video. Thank you.